welcome back to my channel. Today we are going to learn chapter 7, Geometrical Optics. So in this video, we are going to discuss 7.2, Refraction and a Spherical Surface. Okay, so for this subtopic, we are going to use two equations, okay, to solve the questions related to the spherical surface. So the first equations that we will use is n1 over u plus n2 over v equals to n2 minus n1 over r. Okay, and the equations that we use here, n1 here usually is the medium where the object located. Okay, so make sure that a real object located, so that is the medium, and we will label it as n1. Okay, and another one is the radius. Okay, so the radius here, if let's say is positive, meaning that the surface here is convex. Okay, and then we will substitute negative if let's say it's a concave surface. Okay, so this is the first equation that we will use. The second equation is the magnification, where magnification equals to h image over h object, and also equals to negative n1 times v over n2 times u. Okay, so this is the second equation that we will use for the spherical surface. Okay, so let us go to example 6. Okay, example 6. A hydraulical glass rod in the air has a refractive index of 1.52. Okay, one end is ground to a hemispherical surface with the radius of 3 cm. Okay, so here this is the glass, okay, where the radius here is 3 cm. Okay, meaning that we have two medium. The first one is the air, the second one is the glass. Okay, as I mentioned just now, n1 is the medium that the object located. Okay, meaning that our object is here, so air is n1, glass is n2. Okay, so we will use the equations n1 over u plus n2 over v equals to n2 minus n1 over radius. Okay, where n1 is the medium that the object located, so n1 is 1 because it's air, and u is equals to 10 cm, plus n2 is the refractive index for the glass, so it's 1.52. Okay, v is the image position, so this is unknown, so n2 1.52 minus 1.0 over r is 3 cm. Okay, therefore v, the image distance, is equals to positive 20.7 cm. Okay, so positive here indicate that this is a real, okay, real image. So real image for refraction is formed opposite side with the object. Okay, so meaning that it will form at the second medium, so this is the image form. Okay, this is the image form, this is the object. Okay, so the real image will form opposite side with the real object. Okay, next we will go to B. Okay, determine the linear magnification. Okay, so we will use the second equations, where the second equation, magnification is equal to negative n1 times v over n2 times the object distance. Okay, so negative n1, v is positive 20.7, n2 is 1.52, and the object distance is 10 cm. Okay, therefore the magnification is equal to negative 1.36. Okay, so here they give you two information. The first information is negative. So when n negative, meaning that it's actually inverted. So later the image form will be inverted. The second information is n is greater than 1. So when n is greater than 1, actually is magnified. Okay. Next, example number 7. Okay, an object O is placed 10 cm inside the spherical surface with the radius of 15 cm. Determine the image distance. Okay, so as I mentioned just now, we always refers to the object. Okay, so now object is at n1. N1 is actually, okay, the object is actually at the right hand side. Okay, so this is the reflected surface. Okay, meaning that n1 is actually 1.5. Okay, the spherical surface, and n2 is air. Okay, so meaning that our reflector is from right to left. Okay, just now example 6 is from left to right. So now, because the object is, okay, the object is on our right hand side, so this is our object. Therefore, our reflector is from n1 from right hand side reflected to, okay, to n2 to left hand side. Okay, so the equation we can use to determine the image distance is n1 over u plus n2 over v equals to n2 minus n1 over r, where n1 is 1.5, u is equals to 10 cm. Okay, n2 is the air, v we don't know. Okay, so n2 is 1 minus 1.5 over the radius is 15 cm. So again, okay, when we view from right to left, okay, so the surface here is actually a concave surface. Therefore, here we must substitute negative, indicate that this is a concave surface. Okay, so the final answer that we will get for the image form is equals to negative 8.6 cm. Okay, so negative here indicate that this is actually a virtual image. Okay, so a virtual image will form same side, okay, same side with object. Okay, so it will form same side with the object at here. This is the image form where the distance here is 8.6 cm. Okay, so just now our U here is actually 10 cm. Okay, so it will form same side with the object. Okay, this is the reflected surface. Okay, next we'll go to the next question, example 8. Okay, example 8 is actually a glass sphere. So later we will have two. Okay, we have two reflected surface. Okay, so the first one is, okay, this is the first reflected surface. The second reflected surface is, okay, on the other side. Okay, so we look at the first one first, where we will reflect from air is N1 to the glass sphere N2. Okay, so the object at here meaning that air is N1. So we will find the image distance where N1 over U plus N2 over V equals to N2 minus N1 over the radius. Okay, N1 air, so it's 1.0, U is 20 cm, N2 is the glass sphere, so the glass sphere reflected index is 1.63. Okay, V we don't know. Okay, N2 is 1.63 minus 1 over the radius, where the radius here is given 5 cm. So I will substitute 5 cm. And again, when you substitute R, you need to consider the sign convention. So now our reflected ray is from air to glass sphere. Okay, so from air to glass sphere meaning that we are viewing from left to right. Okay, so when we view from left to right, actually it's a convex surface. Okay, so when it is convex surface here, we must substitute positive because it's a convex surface. Okay. Okay, so the V, the image will form positive 21.5 cm. Okay, so positive here indicate that this is a real image form. Okay, where real image will form in opposite side with the real object. Okay, so from the reflected surface, okay, it will form at the distance of 21.5 cm. Okay, so we know that this is already 5 cm. The radius already 5 cm or the diameter is 10. Okay, so here from the second surface is 11.5. Okay, so this is the first image form where the first image form here will become object for the second reflected surface. Okay, so now we look at the second reflected surface, which is at the second part on the right hand side. Okay, so this one red color I wrap. Okay, this one I cancel off. Okay, so now we are referring from glass sphere to the air. Okay, from glass sphere to the air. Okay, meaning that it's like that. Okay, so meaning that our first reflected surface and this is our second reflected surface. So our first time reflected is from 1 to 2, meaning that from air to glass. Okay, then later the second reflected is from 2 to 3. Okay, meaning that from the glass sphere it will reflected out to the air. Okay, so just now is red color, the surface is 1 to 2. Okay, now the second reflected is from 2 to 3, meaning that is from a glass sphere, okay, reflected out to the air. Okay, so now our equations, similar, we will use N1 over U plus N2 over V equals to N2 minus N1 over the radius. Okay, N1 because we are reflected from glass sphere to air, okay, meaning that N1 is actually glass sphere, N2 is the air. Okay, so as I mentioned just now, usually N1 is the, okay, it's the medium where the real object located. Okay, so meaning that if real object at N1, meaning that the real image will form at N2. Okay, but if it refers to this diagram, okay, we found that actually the image just now, image 1, or it will become object 2. Our object is actually, okay, on at the N2. Okay, it's outside. Okay, it's in the air. Okay, meaning that actually this object is actually a virtual, okay, it's a virtual object. Okay, because it is located at the air. So it's actually in N2, on inside the N2. So meaning that this is actually a virtual object, because if N1 is the glass sphere, our object, okay, it should at our left hand side. But now our object is located, okay, on our right hand side. So meaning that this object here, okay, is actually a virtual object. Okay, so we must substitute in the virtual object is negative because it's virtual object at the distance of, okay, 11.5 because we are referring from the second reflective surface. So from the second reflective surface, the distance U is 11.5. Okay, so we substitute inside where N1 is the glass sphere, where the glass sphere, the refractive index is 1.63. Okay, U is, okay, from the refractive index is 11.5. Okay, so it's 11.5 okay, and we must substitute negative because this is virtual object. Okay, your object should on our left hand side, but now our object is formed on our right hand side, therefore this is actually a virtual object. Okay, plus N2, because we reflected from glass sphere to air, so N2 is air over V, 1.0 minus 1.63 over the radius, where the radius is 5. So again, when you want to substitute the radius, you must refer back. Okay, now our reflector is from glass sphere to the end. Okay, so this is the reflective surface, and we view from left to right, therefore this is actually a concave surface. Okay, so we must substitute here negative, okay, because this is a concave surface. Okay, therefore the final image form, this is actually V2, okay, is equals to positive 3.74 cm. So positive indicate that this is a real image. Okay, so a real image must form opposite side with a real object. Okay, meaning that it will form, okay, it will form at the distance of how much? 3.74, okay, on medium 2, meaning that it will form at here. Okay, the image 2 will form at here 3.74 cm from the second reflected surface. Okay, so this is the image 2 it will form. Okay, because our real object is at here, meaning that our real image should form at N2. Okay, so this is the image form, okay, where it's equals to 3.74. Okay, next we go to example number 9. A small strip of paper is placed on the side of the glass sphere with the radius of 5 cm. The paper is then viewed from the opposite surface. So determine the positions of the image where the glass reflecting index is 1.52 and the reflecting index of the air is 1. Okay, so we imagine that there is a paper stick placed on the glass sphere. Okay, so the surface, okay, the surface here is actually, this is the surface, because the other side is actually the paper pasted there. Okay, meaning that the value for u is actually the diameter. Okay, so the radius is 5, so the diameter here, our u is equal to 10 cm. Okay, and this is our object, the paper. Okay, so this is our object, meaning that this is N1, here will be N2. Okay, so now equation N1 over U plus N2 over V equals to N2 minus N1 over R, where N1 is the on our right hand side, okay, which is the glass, so it's 1.52, U is 10 cm plus air 1.0, V we don't know, 1.0 minus 1.52 over the radius is 5 cm. So again, 5 cm, when you want to substitute, you need to consider the sign convention. Okay, so if you view from N1 to N2, from the glass sphere to the air, the surface here is actually a concave surface. So when it's concave surface, okay, we must substitute negative. Okay, because this is a concave surface when we view from N1 to N2. Okay, meaning that from this case, we are viewing from right to left. Okay, therefore the equations, the value, the V that we will get is equals to negative 20.83 cm. Okay, so again, negative here shows that this is actually a virtual image. So a virtual image will form same side with the object. Okay, so if your object is at the 10 cm from the reflective surface, therefore this is 20.8, so it will form at here. Okay, so this is the image form. Okay, same side with the object 20, okay, 20.83 cm. So this is our V, okay, from the reflective surface. Okay, next example number 10. So again, example number 10 is the glass sphere. Okay, so when it's a glass sphere, meaning that it will have two reflective surface. The first one, okay, is from air to the glass sphere. The second one is from the glass sphere up to the air. Okay, so we will do one by one. Okay, so number 1, okay, I label. Let's say this is 1, this is 2, this is 3. So first round is between 1 and 2. Okay, 1 and 2. So I wrap this one first, 1 and 2. Okay, where N1, because the object is at here, meaning that this is N1, the glass sphere is N2. Okay, so we substitute N1 over U plus N2 over V equals to N2 minus N1 over R. Okay, so N1 is air, because our object here is located on our left hand side. So N1 is air, U is 15, plus N2 is the glass 1.52 over V equals to 1.52 minus 1 over the radius, where the radius here is given 10 cm. Okay, so I will substitute 10 cm, and again, when you want to substitute the radius, you must refer to the surface. Okay, so if you view from N1 to N2, actually the surface of reflector is actually convex. So when it's convex, we must substitute positive, indicate that this is actually a convex surface. Okay, therefore the first image form, okay, from the first refractive surface is equals to negative 103.63 cm. Okay, so again, negative here indicate that this is actually a virtual image. Okay, so a virtual image will form same side with the object. Okay, so from the refracted surface, it will form same side with the object. This is our object. Okay, so it will form 103.63. Okay, so the image will form at here. Okay, the image will form same side with the object. Okay, next is the second refractive surface. So this is the second refractive surface. Okay, so I will wrap the first one. Okay, where the second refractive surface is actually, okay, it's actually from the glass sphere to the air. Okay, from the glass sphere to the air, meaning that N1 is the medium that the object should locate. Okay, and this is our refractive surface. Okay, so we can use the equations N1 over U plus N2 over V equals to N2 minus N1 over R, where N1 here is on our left hand side. Okay, it's the spherical glass, so it's 1.52. Okay, U is the image. This image later will become object to the second refractive surface. So the second refractive surface here we are referring, okay, is this surface, meaning that our U is actually, okay, our U is actually 103.63. Okay, 103, sorry, is equals to 103.63. Okay, you must plus the diameter. So the diameter is 10, so 10 plus 10, so become diameter is 20 lah. Okay, okay, plus, okay, plus N2 is air, V we don't know, so it's 1 minus 1.52 over the radius is 10. Okay, again, the surface here is actually a concave, so we must substitute negative because this is a concave surface. Okay, so finally the value V that we will get is equals to positive 25.2 cm. Okay, so positive here indicate that this is a real image form, and real image form will form opposite side with the real object. Okay, so the real object is on our left hand side, meaning that the real image form, it will form at here. Okay, from the refractive surface, the second refractive surface, it will form 25.2 cm. Okay, so this is the second image form. Okay, image 2. Okay, here. Okay, so that's all for this subtopic. We will continue with 7.3. We will continue with thin lens. I'll see you on next video. Bye.